And as you might know, we are still an Austrian-based company. We are manufacturing our products in Austria. And we were founded in 1945. And our main idea was always a sustainability focus. So the founder, who you can see here on the picture, invented the first battery charging device. So that enabled basically recharging car batteries and not making them being thrown away once they are dead. And the main invention there was really transforming the energy between AC and DC. And that's still the main core of all our products up to until today. We are now already in 3 different areas, 2 strategic businesses basically. The first one is solar and energy. So we are producing solar inverters and battery charging devices still. And we now also have the welding department, which is really focusing on everything around welding equipment, from the small hand pocket welders for everyone at home up to the big robots welding automotive systems and cars basically. So, and I just quickly want to walk you through a whole product life cycle and show you what we are doing there in terms of AI. So usually when you're starting, there's technology development, you have a pre-development phase, and from that pre-development phase, you're usually trying to transfer the knowledge that you gained in there to product development. Then, usually the product needs to be manufactured, and then the product is in use at the end customers. Does it work again? Okay, perfect. The product is in use, usually, especially in the inverter field and in the welding field, for a couple of years, so 20, 30 years plus. And then there's somewhere still the end of life of the product, at least after some repairs when you really can't do anything anymore with the products. So, what are we doing? In technology development, for us, it's all about research. So we are having at the moment a couple of research projects focusing on all different areas. In solar and energy, there's a big focus on embedded AI, so bringing the AI models really on the embedded devices, because when you're controlling energy and electricity, it's really vital to have real-time adjustment and real-time optimization on the device in order to not lose that much optimization potential. We are working on explainable AI, which was already mentioned by Infineon. That's also really crucial for us, because when you're in an critical infrastructure sector, as we are in solar, it's vital that you can explain to the end customers what is going on in their devices. And if you have an AI algorithm that is optimizing your PV system, the user and end customer usually wants to know why the algorithm is doing what it's doing at that certain time. In welding, there are 2 projects. First of them, the manufacturing is nearly done. And there we are already more on the pre-development phase. And the second one, it's all about mainly data analytics yet, and also connecting all the data sources from our robots, etc. that we have. In pre-development, on the one hand side, we are working on forecasts and weld seam quality prediction. If you think about a welding device and weld seams in industry, usually 80% of the costs of a specific weld seam are caused by the visual inspection and the manual inspection of the weld seam afterwards. If the weld seam is okay, or if there was a burn through or something like that. So there's really quite a huge cost improvement and cost saving potential there. That's why we're working on developing AI algorithms and detection algorithms that can detect these holes, burn-throughs in the weld seams just based on our system data. So we have the data from all our robots, and we are really using to try and use that data to detect these faults in the weld seam. Despite that, we are already working on AI-based energy flow management. That was part of my PhD thesis, but we also have multiple different approaches there. So from reinforcement learning to neural networks, and I was specializing in genetic programming with symbolic regression. For the product development, we are also working on GenAI. So we have our own GPU servers where we are working on some sort of a digital assistant really for our employees in order to enhance our data interaction. And in manufacturing, that's quite a general use case, I would say, which is usually used very well. There we are working on really camera-based quality assurance. So we have the cameras mounted on our production lines that check is the part on the place where it should be and if it's used correctly. Oops, that was one too early. In product usage, that's really the features that we already have in production environment. We have mainly in solar energy forecasting algorithms. So in order to have some sort of an AI-based energy management system, you need to know or should know what the forecasts or what the system will do the next 24 hours. And therefore we have forecasts for the production of the energy system. We have forecasts for the energy consumption of the building. And together with that, you will be able, and we will be able to in the future really optimally control the energy flows of the residential buildings, of the PV system at home. Despite that, like for internal products, we're also using some sort of demand forecasting tool, which helps us to predict the installation of our systems and then from there derive what we need to produce in order to fulfill the needs of the customers. And I think I'm in time, so thanks a lot. If you have any questions, just reach out to me later on too.
So, any questions? So, like, with a
Thank you very much for this speed. So I had just one question on that. So you have like this KI tools functionalities in your processes already. So what have you done to really have this scalable phase of having that really in your processes?
It was quite a learning journey. So we really started completely from scratch. We didn't have anything. And within like 2.5 years, we managed to set up our whole AI toolchain and infrastructure from scratch. So we're mainly focused on open source. So we built our toolchain around Argo. And with that, with like tons of clusters and all that calculating and research capability that we have, we managed to bring those forecasts at the moment into production environment. But yeah, it was a steep learning journey and it was sometimes also quite painful.
Thank you.
Any more questions? So maybe, so you mentioned Fed AI,
yeah.
Federated AI systems,
yes.
Federated learning.
Yeah.
So can you, so what kind of scenario would that be, for example, in your case?
Yeah, on Fed AI, we are working for both strategic business areas, so for welding and for solar. For solar, it's really about intelligently connecting the inverters in order to achieve some sort of grid optimization and grid stabilizing inverter behavior. And for the welding, it's mainly focused around robotics. So really connecting the robots in one factory with each other so that, for example, one robot has done a faulty weld seam, that these informations can be exchanged in an intelligent way in order to prevent other robots from failing.
Okay. If there are no further questions, then let's thank the speaker again.
Thank you.